So this is problem 3 on week 64 quiz. And it says the prime sum radical of a number n is the sum of the distinct prime divisors of n. For example, the prime sum radial of 45 is 8 and the prime sum radial of 42 is 12. How many integers from 2 to 1000 inclusive have a prime sum radial of 10? So we look at this and we say the only two options here are if it has 2, 3, and 5 as their prime divisors, or 3 and 7. And we also realize that we know that 30 works here because it only has 2, 3, and 5, but 210 doesn't work because now it has 7 in it, so it's 2, 3, 5, and 7. And the prime sum radial would be 17 instead of 10. And so it has to have like 2 squared times 3 squared times 5, or 2 to the 4 times 3 times 5, and no other way. So we'll just look at this and do casework. So if there's one factor of 2, 2 to the 1, then how many ways are there to have 3 and 5? So we have times 3 to the 1 times 5 to the 1. That's one way. And we also have 2 to the 1 times 3 squared times 5 to the 1. Wait, no. We'll just do casework by increasing, and we'll stop when we have a place where we end, or we surpass 1,000. And we also have 2 to the 1 times 3 to the 1 times 5 cubed, which is 750. And we can't multiply by 3, so this chain ends here. And so this is the 2 to the 1 times 3 to the 1 chain. And we'll have another one, 2 to the 1 times 3 squared now. And we know times 5 to the 1 works. 5 squared works, I think. That's just 6 times 9 times 6. No, that's just 2 times 9 times 25. It's 50 times 9. That's 450. And that works. And no, we can't add another power of 5. So this is the 2 to the 1 times 3 squared chain. And we'll have another one, just 2 to the 1 times 3 cubed. And we times 5 times 5 squared. But can you times 5 squared? No, you can't. So it's only times 5, and that's the only one that works. And so this is the 2 to the 1 times 3 cubed chain. And another one, which is 2 to the 1 times 3 to the 4th times 5. And that's the only one that works. Yeah, that equals 800 something. And so we can't add any more 3s to this chain of 2 to the 1s. 2 to the 1 times 3. Well, actually, we don't even need this. We'll just group them in one box later. It's 3 to the 4th. That's what the chain is. And so let me just fix things up here. So we can just group this all up into 2 to the 1. And I just cut off part of it so we save time. And so that's just 2 to the 1. And so we have a shortcut here. So we can just times everything by 2 to get our 2 squared chain. And so in our 2 squared chain, this part would not exist. The 3 to the 4th chain would not exist here. And this equals to 2 times 27 times 20 times 5. And this is 270, so this would fit. Yeah, this would. And so this goes in to 2 squared times 3 cubed times 5. And I won't be labeling the chains here. And so this part also works, but yeah, this part also works for all of them. So 2 to the 1 times 3 squared times 5 to the 1, 5 squared. And so both of those work too. And we have 3 to the 1. So do all 3 of these work? Yes. Well, actually, no, they don't. This one here doesn't work. So we only have 2 of them now. So we'll have 2 to the 1 times 3 to the 1 times 5 to the 1 and 5 squared. This is actually 2 squared. And so, as you see, this would take a pretty long time if I'm explaining it while I'm doing it. So, I'll just do the rest here. I'll just do some of it here and y'all can see where I got it from. And so, here's like a completed version. And as you can see, I've continued from this chain all the way here. All the way to 2 to the 6 times 3 to the 1 times 5 to the 1. And so if you count, which there is 1, which there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there are 19 of these. 2, 3, and 5 times some radicals. And you come here to 3 and 7. And it's much easier casework this time. So you just do by 3 and 7. So 3 times 7. 3 times 7 squared. 3 times 7. Never mind. That doesn't work. So that's one way. Another way is 3 squared times 7. And we repeat the process. 7 squared. That's it. And 3 cubed times 7. That doesn't work. And finally, 3 to the 4th times 7, which fortunately works. Actually, which it just works. And so there are 6 of them in here, in contrast to the 19 there were last time. So in here, there are 6 of them. And so, shoot. If we add these 2 cases up, then we get 3 squared times, my bad guys, 3 squared times 7 squared. Okay, this is so just 3 squared times 7 squared, my bad. Okay. So if we just add these 2 numbers up, then we get 19 plus 6, which is 25. So that's just our answer, which is 19. 19, my bad. 19 plus 6, which is just 25. That's our answer.